What's up guys, welcome back to Kit Guru. So today is another PC chassis review. This is actually a new case from a company called MonsterLabo. You might not have heard of MonsterLabo before. This is actually only the second case from this company. The first one was reviewed a couple of years ago by Leo. It was a much more compact unit that took just a mini ITX board. It was actually called The First. This one is called The Beast. The Beast is more of an ATX style chassis. It's definitely not ATX form factor, but it does share some similarities. It's similar in dimensions to an ATX chassis, probably a little bit taller than what you'd expect from a modern ATX chassis, and it's also probably slightly narrower from front to back as well. It does take up to a full ATX motherboard, also micro ATX, mini ITX as well. That's basically where the similarities between the Beast and an ATX chassis end, because this is really unique. The Beast comes equipped with a complete cooling solution for the whole system. So the CPU and the GPU is cooled in essence by the case. Let me show you what I'm talking about, because once you remove these two tempered glass side panels, one on each side, it becomes pretty evident why the case does the cooling. As you can see inside here, there's two giant heat sinks. These weigh about 3 kilograms each. One of the heat sinks is for the CPU, one's for the GPU. Each heat sink has 10 6mm diameter heat pipes, and then there's also 6 thermal drains that connect the heat sinks to the outer chassis for additional dispersion of the heat. It's a completely silent PC chassis, so if you pair this with a fanless power supply such as the Seasonic unit that is installed at the moment, there'll be no moving parts whatsoever inside the system. So there's no fans, no moving parts, so that means complete silence. The only slight noise you may be able to hear under load is maybe coil whine from the GPU, depending on the GPU. So if you're looking for a completely silent PC case, this could be exactly what you want. The only stumbling block I can see initially with this case is the price. The Beast costs in standard form €790, which sounds like an absolutely astronomical amount of money for a PC case, but you've got to remember you are getting a complete cooling solution as well. If you was to go out and buy all the parts for a custom loop, it'd probably cost you a similar amount depending on how many radiators and pumps, water blocks you want in the system. So maybe it's not too bad a value. As you can see as well, the motherboard and GPU are not mounted in the traditional way. The motherboard is kind of like floating at the side of the system. And because of this unique mounting system, it means that the Beast is compatible with ATX, micro ATX and mini ITX motherboards. What's basically happening is the CPU block is mounting the motherboard and holding the motherboard in position. And actually it's surprising how sturdy it feels, really. I'm surprised by that. I thought it would probably be a bit more flex and stuff in it, but it does feel pretty solidly mounted in place. As well as good motherboard compatibility, you can also install high-end graphics cards up to 290mm long, and that's with the stock cooler removed, because you have to remove any stock coolers to install it inside the Beast. So in passive mode, without any fans installed, the Beast will dissipate up to 400 watts of heat in total. 150 watts on the CPU side and 250 watts on the GPU side. There's also the possibility to install 2 fans in the top of the system, and in assisted airflow mode, the Beast can handle up to 600 watts of heat. MonsterLabo has also collaborated with EK water blocks, so for any graphics cards installed into the system with a 220 watts or higher TDP rating, there's a VRM and VRAM heat spreader for the GPU as well. And that also means that the backplate is compatible with EKWB backplates as well. The case comes with a PCIe Gen 4 riser cable, and you can also customize the case when ordering as well. The default configuration would be just in a plain black coating, but you can have these special color coatings as well, which cost €100 each. So we've got this red powder coated finish. If you look on the MonsterLabo website, you can see there's various different colors that you can have the case powder coated in. And also on this front panel, you can have a customized logo or something like that laser etched into the panel, as well as being able to buy the Beast just as a bare chassis, obviously with all the cooling hardware and everything to install the system inside. You can also buy it into pre-built system configurations as well. There's an extremely fanless configuration that has either a Core i5 12600K or an AMD Ryzen 5 5600X paired with an RTX 3070, or there's the insane configuration and that has an RTX 3080 paired with either a Ryzen 9 5900X or an Intel Core i9 1200K. The extremely fanless version, that is priced at €2,850, and then the insane configuration, that's at €3,600. So before we take a closer look at the Beast and do some thermal testing on the case, don't forget to subscribe to the channel. Make sure you hit that like button if you enjoy the video. If you want to help support Kit Guru, head over to our store and pick up some merch. And as always, if you want to catch up on the in-depth technical reviews, head over to the website. So at €790, we've got to say that this is a premium product. However, the design, especially the aesthetics of the case, are really minimalist and look quite basic actually. The front and rear panels are just made up of a 6mm aluminium sheet, and you can see the bottom of those panels are bent to create feet. We've got a lot of front I/O connectivity. There's a large power button in the middle, reset button, a USB Type-C port, and two 3.5mm audio jacks. And then on this side we've got two USB 3.0 and two USB 2.0 Type A ports. So that's good front I/O connectivity. Some mainstream cases, you don't get anywhere near as much connectivity as that. The tempered glass side panels that we were talking about earlier are fitted on both sides of the case. You don't have to have them installed. They just locate on these latches, so to speak. These are actually really cheap, these latches. I use these on like a cupboard underneath my stairs. You can probably pick these up for a pair any hardware store for less than £1, I'd say. And it doesn't make it easy to install the glass panels. I think it's really fiddly, and you have to put a bit of force on the panel to get it on. I think a hinge design would have been better than that. They are easy to remove though. Just pull them off at the bottom and they come off. Get a better idea of how awkward they are this way around. Not the easiest thing to use, but they do work. So as well as the removable tempered glass side panels, the top panel is also removable. Again, this is just made out of a 6mm plate, bent into shape, and you can see at the top there's a large cutout and then a vent as well up there. Just got to mention something about this as well, because this is kind of held in place. It's almost like an interference fit, but there are some really small like ball catchers that hold it in position. On 3 of the corners it's held down well, but at this side the ball catch doesn't really seem to be doing much, and it just basically flaps around pretty freely. And also the mesh, if you press on the mesh, it also pops it up as well. So not really what I'd expect from a premium product that costs nearly €800. But you can see it is quite tightly held in place, that top panel, and like I said, you can just see there is 6mm aluminium, and then there's these kind of brackets that are welded to it, and that's where the ball catchers locate on. You've also got this bit of mesh as well. I'm not really keen on that either. It looks like something you'd get in your outdoor barbecue, and you can see the paint's already started flaking off there as well. I think there could be a better solution for that. Maybe if it was welded in position, or maybe even if the mesh was laser cut out of this aluminium piece. I don't think that's really that good, to be honest. And also, it's quite noisy if you press on it. It's not good. I don't like that. I don't like that at all. But I imagine the majority of people that use this would potentially just have this aluminium piece on, and makes it more open for the natural airflow as well. I think if I was using this case, I'd probably use it open and not bother with this mesh piece. I can see why this is here. It's to stop any small pieces dropping into the system, but I don't like that design, and it's not a very good fit either as well. it moves about, paint's flaking off it, so I'm not too keen on that. The coating as well on this it's a powder coated finish. You pay extra for this at MonsterLabo. It's an extra €100 to have one of the special colours. The powder coating's not bad. On this top panel, it's pretty smooth, quite glossy finish. But you can see, especially on the front panel, I don't know how well the camera gets it, but it's got a bit of like an orange peel finish to it, which isn't brilliant. I know MonsterLabo are actually applying this powder coated finish themselves in their factory, and I've spoken to them about it, and they are trying to improve the finish. And according to MonsterLabo, the retail units will look better than this, which again makes me wonder why they've sent one to me that doesn't look too good. But anyway, hopefully retail units will be better, because there are some areas as well on here that the coating hasn't quite fully covered, so it's not as good as I'd like to have expected it to be. Because of the way the motherboard is installed in the system, you don't get a normal rear I/O setup at the back of the system. The motherboard orientation has the I/O ports facing down at the bottom here, so you can see you've got a series of cables that run from the motherboard I/O to the back of the case, and then the actual I/O ports, they're on kind of like these modular plates, so you can add or take away whatever you need depending on your motherboard. And I suppose the good thing about those modular plates is if somebody came up with a completely different port in the future, you could have one maybe custom laser cut or 3D printed or something like that yourself, and then you know you can upgrade to a new connector. With the motherboard that's installed in this system, we've got 4 USB ports there. Graphics card as well uses the same setup with the extension, so there's 2 display ports and a HDMI port, and then a Cat6 Ethernet port in there as well. Also, down on the floor of the chassis, you'll notice there's this bracket here. This is for installing storage drives. The retail units will come with 4 of these removable brackets that you just take out the thumb screw, and then this piece slides out. And these are for mounting your mechanical 3.5 inch drives too, so you just screw your drive to that. And then the drive just slides back in position and is mounted in a vertical orientation. There's also alternative mounting holes for 2.5 inch drives. You can see those line up with the holes, so again, just screw your 2.5 inch drive to the bracket, slot the bracket back in position, and that's mounted in the same way. So as I mentioned earlier, the Beast can be bought as a fully pre-built system. There's those 2 preset configurations, but you can also have a custom build as well, so you select the specification, MonsterLabo will build it for you. There is a charge for that, it's €300. Ours came as a pre-built system, and it is a custom configuration. The CPU is an AMD Ryzen 9 5950X, and the GPU is a Zotac RTX 3080 Ti. So I didn't actually get a chance to build the system myself, but I have had a play around with it, removed components, put them back in again to see how difficult it would be to build a system in here. It's certainly not like building in any other ATX case you've ever built in before. As you can see, the motherboard is mounted with the back facing outwards, so if you want to do any maintenance on the system in future, it's going to be quite difficult getting into anything to unplug it. When you want to install the motherboard, the best thing to do is install everything you can to the motherboard, so CPU, RAM, any SSDs need to be installed first, and then you have to connect up all the cables as well, and then it's basically just held in position via the CPU block with these 4 spring-loaded thumb screws and washers. So it is like nothing else to install. And then the GPU, again, is quite tricky as well to install. So after you've removed all the stock cooler from the GPU, if it's higher than 220 watts TDP, you have to install the heat spreader plate to the heatsink first, and then mount the card and the back plate to the heatsink, and then connect it up to your PCIe Gen 4 riser cable. So it'll probably take you a bit longer to build this system than it would with a standard system, especially if you're an experienced builder. You'll find that it is a different way of building a system. I wouldn't say it's that much more difficult, it's just you need to be aware that everything is connected up before installing the motherboard to make sure you don't have to then strip it down again afterwards. MonsterLabo also wanted us to test this in passive mode. So because of the configuration that we've got, it actually exceeds the 400 watts that the passive coolers are rated for. MonsterLabo has actually done some detuning on the graphics card. So what they've done is basically set it up with a custom frequency voltage curve, and that keeps the power draw to 250 watts. If you do want to run the system in an assisted airflow mode, you just need to remove this top panel, and then as you can see in the top, the heat sinks are shaped to accept fans. So if you just take a 140mm fan, that just sits in place on top, and you can have one for each heat sink, and then they'll assist the airflow and hopefully improve the thermal performance. And that's what I'm going to do now. I recently built myself a similar spec system to this with a 5950X and a 3080 Ti Founders Edition card. So I'm gonna set that system up in the same configuration as this in terms of the GPU frequency, and we'll do some side-by-side testing, see how this completely passive system compares to a traditional system with traditional cooling. So I've got both systems here. The Beast is on the desk, set up, connected to this monitor, and then the comparison system is behind me here, and that's set up to this second monitor. I've configured the comparison system with the same GPU settings, so it shouldn't exceed 1650 megahertz on the boost, and the power draw should be around about 250 watts, which is the same as how MonsterLabo set up the Beast. So the first thing I want to do is run a CPU stability test using Cinebench R23, so I'll set it to the 30-minute stability test. And I'm using HWinfo to measure the CPU temperature. You can see we've got a graph for the CPU temperature here, the average CPU clock, which is on this graph, and then the GPU temperature and the GPU clock. We'll not see much on these two on this first test, but I'm going to run some GPU tests as well afterwards. On the other monitor, we've got the same graphs up there as well, and you can see at the moment CPU is idling around about 45 to 50 degrees C on the Beast, and then on the other system it's between 40 and 45 degrees C. So even on idle, there's about a 5 degrees difference in the CPU temperature. The CPUs in both systems are configured just stock, so there's no overclock or undervolting or anything on the CPU. So I'll run both these tests at the same time, so it'll be the multi-thread test. So we can set both these going at the same time, and we can do a proper side-by-side test. Ambient temperature in the room at the moment is about 23 degrees, so it's probably what I'd call perfect running conditions. And because we're doing these tests side by side, we don't really need to take the ambient temperature in the equation at all. So let's see how they go and bring the graphs up, and we can see exactly what's going on. So we're only about 5 minutes into the CPU test, and it's already quite interesting what's happening. So you can see from the CPU temperature graph, we started off around about 68 degrees, 70 degrees, and it has slowly climbed the CPU temperature. As you can see, it's climbed all the way, and now we're up to 81 degrees on the Beast system. And you can see how that has affected the CPU frequency as well. So we started off around about 3.8 gigahertz, and as the CPU has got warmer, the frequency has dropped as well to compensate. So we're down to just over 3.6 gigahertz now on the Beast, and the temperature does fluctuate obviously as the Cinebench test starts and stops, but we are around about 80 degrees on the Beast now. But if you look at the comparison system, the temperature on that started off around about 69 degrees, 70 degrees at the beginning of the test, and it's still at the same temperature now, and we are 6 minutes in. And the frequency on the comparison system is started off at 3.8 gigahertz, 3.85, almost 3.9 gigahertz, and we're still at 3.85 to 3.9 gigahertz now. So you can see how the higher temperature of the beast is affecting the CPU frequency, but you can see we're pulling 122 watts at the moment. It's around about 122, 125 watts on the CPU. So to say there's no fans in this system, it is quite impressive that it's keeping the CPU within AMD's spec. It's still below the maximum temperature recommended by AMD. So far it's looking pretty impressive. And you can hear as well, if I just unclip my microphone, there's absolutely no sound coming from the beast at all. I have configured the fans on my own system to run as quietly as possible. So if we can get my microphone near that. You can hear that that's pretty quiet as well. I definitely wouldn't be disturbed by the noise coming from that system if I was concentrating on work or anything like that. So we're about 20 minutes into the test now, and it looks like the CPU temperature's almost leveled out on the beast. You can see it's running about 85 degrees C now, and that has had quite a drastic effect on the CPU frequency. We're down to below 3.6, so we're in between 3.5 and 3.55 gigahertz, and the CPU package power is still around about 122 watts. And you can see that on CCD1 we've hit a maximum 93.8 degrees C, which is getting pretty toasty. So it looks like under a prolonged load, the system, or the CPU I should say, does get pretty toasty in the beast. If you put your hand over it, you can feel some of the airflow coming from that natural convection. So it's doing its job, but it is affecting the CPU frequency. I did expect that. I'm not expecting this to perform the same as something that's cooled with an all-in-one CPU cooler or a big air cooler with a fan on, but it's still doing a pretty good job. I'm quite impressed actually by the CPU temperature. At 122 watts, we are within the rating of the CPU heatsink. So it's not a massive surprise, but it is looking quite promising. Just as a reference point, the traditional cooling on the other system, that's virtually run at the same temperature all the way through the test. We're just under 70 degrees C, and the frequency of the CPU hasn't budged really. It's still around 3.85 to 3.9 gigahertz. I've not mentioned as well, this system is using a 360mm all-in-one CPU liquid cooler with Be Quiet, Silent Wings 3 fans. So as well as the temperature kind of flatlining all the way through the test, the noise from the system hasn't increased either. So I don't know, obviously the traditional system is running cooler and the frequency is better, but this is doing a pretty good job so far. Okay, so that test has finished, and we get a score for each system from Cinebench after the test has finished. So on the traditional system, we got a score of 25,017, and then the Beast gave us a score of 24,009. So that is about a 4% drop in performance with the Beast due to the CPU frequency. And as you can see, we peaked at 87 degrees C on the Beast, which is pretty toasty, but it's still within AMD's spec. Individual CCDs peaked at 93.8 degrees C, and the frequency at the end of the test dropped to still between 3.5 and 3.55 gigahertz. When compared with the other system, temperature remained virtually the same throughout the test, just under 70 degrees C, and it's the same for the CPU frequency as well. That was between 3.85 and 3.9 gigahertz. So you are compromising on performance a little in terms of the CPU for performance with the Beast, but 4% it's not bad. If you need a completely silent system, maybe it's worth making that sacrifice in performance. So I'm just going to let everything cool back down, get back to normal idle temperatures, and then after that, when everything's back to normal, going to run some GPU tests as well. Before I run the thermal tests on the GPU, I want to run a TimeSpy Extreme benchmark on both systems. So I've just temporarily set this back to stock on the GPU, so power limit, temperature limit, frequency, everything's just back to the stock 3080 Ti FE settings. So I'm going to run the 3D Mark TimeSpy Extreme benchmark and see what kind of difference there is in performance between the Beast and the other system. Don't forget, the Beast is still running in a completely passive mode, so that means the GPU is still underclocked to 1650 MHz. Power draw is restricted to around 250 watts. I just want to run this benchmark on both systems to see what kind of compromise you're having to make with that GPU underclocked as much as it is. So let's leave these to run, see what happens. So TimeSpy Extreme benchmark's finished, and you can see the scores: 9,498 on the comparison system and 9,149 on the Beast system. Again, that's about 4% drop in performance on the Beast. A little bit less, maybe 3.5 to 4%. So not too bad actually. I'm quite impressed with that score. It's, you know, it's not a real big compromise on performance during quite a short test though. The TimeSpy Extreme benchmark. You can see the GPU temperature peaked at about 70 degrees C, which again is perfectly fine. But as I said, it's only a short benchmark, so it's not a prolonged load like we saw on the CPU test. GPU power peaked at just under 280 watts as well, so pretty good. It sounds like the heatsink on the GPU can handle those short bursts of GPU temperature, so that's pretty good. And just to put that into perspective, maximum temperature on the GPU on the comparison system just over 70 degrees, and that pulled 300 watts during full load. So it's not bad. There is a compromise between performance and noise levels and temperature with the Beast, but during a short burst on the GPU seems perfectly fine. Now I want to switch from the benchmark and run the 3D Mark TimeSpy Extreme stress test. So that will that'll test the system over a prolonged period, and it gives you a result at the end to tell you how consistent the frames per second is. So we'll run that again on both systems side by side, switch to the TimeSpy Extreme stress test, so that's the 4K stress test, and run those again side by side, and we'll be back soon to have a look at the performance. So we're less than 10 minutes into this stress test, and you can see the temperature of the GPU in the Beast. It started off around about 65 degrees at the beginning of the test, and it's slowly been climbing all the way, and it's still climbing now, and we're up to 87 degrees on the GPU core, which is pretty toasty. You can see how that has affected the frequency as well. It was pretty solid to begin with at 1680 megahertz, and as the temperature hit around about 85 degrees C, you can see the frequency has started to fluctuate now, and it's dropping down to below 1600 megahertz until we get to here, almost where we are now in the test, and we're down at 1530 megahertz. So you can see you're having to compromise again between the temperature and the performance. On the other system, the GPU temperature got up and it's plateaued at about 66 degrees C, and frequency is between 1650 to 1710 megahertz. So we'll carry on, leave this running. It's about a 30-minute test, so we'll leave it until the end of the test and then have a look and see how much that frequency has dropped. You can see at one point it's dropped below 1500 megahertz already, and as I say, we're only 10 minutes in, so we've got another 20 minutes to go. Temperature's at 87, 88 degrees and still climbing. So we'll come back to it at the end and have a look, see what the final result is. Almost 20 minutes into the test now, and you can see the temperature on the GPU in the Beast has gone over 90 degrees C. That's had quite an adverse effect on the CPU frequency as well. So we're down to 1365 megahertz now on the GPU core. We're still pulling about 240 to 250 watts, so that's within the spec of the Beast's heatsink for the GPU. So yeah, it's having quite an effect on performance, I imagine that, but we'll see at the end of this test as well, because this stress test, it'll give us a result at the end to tell us how consistent the frame rate is. The comparison system, again, it's still sat at 66 degrees on the GPU, and the frequency is still around about 1650 to 1700 megahertz. So let's see what scores we get at the end. Stress test has finished on both systems, and you can see the result on the Beast is 88% frame rate stability. It needs 97% to pass the test, so that's failed on this one. What that suggests to me is that during prolonged gaming sessions with the Beast configured as it is with this graphics card, you might find that there's an instability in frame rate. So as you are playing the game for longer and the GPU heats up, you might see frame rate start to drop and performance start to tail off in games, which is not great. But again, it's always going to be a compromise between performance, noise level and temperature with a passive system like this. So if we just look into the graphs and the temperature and everything in a bit more detail, you can see the GPU peaked at 91.1 degrees C. The memory junction temperature was 100 degrees C, and the GPU hotspot temperature was 98.1, so almost touching 100 degrees on the hotspot temperature. So it's getting pretty toasty. Maximum power draw from the GPU, 276 watts, so that is a little higher than what the actual heatsink is rated for. Don't forget that's rated at 250 watts by MonsterLabo, so yeah, we are seeing that just slightly over the rated maximum. And because of those increases in temperature, the GPU frequency dropped down to as low as 1365 megahertz. If you compare that to the other system, that got us a result of 98.4%, so that passed the test. So if you're just running CPU intensive applications or GPU applications that only stress the GPU in short bursts, you're probably not going to see a huge performance drop, but I suspect during prolonged gaming sessions you might start to see the GPU performance drop the longer you get into a game or whatever GPU intensive application you're going to be running. I also want to see how the system reacts to having both the GPU and CPU under load at the same time. So I'm going to go back to the 3D Mark stress test on both systems, run that a little bit longer this time. I want to see a full 30-minute stress test, and also at the same time I want to simultaneously run the Cinebench R23 benchmark. I've set that to 70 minutes on a custom test. I'm not going to run it for that long. I'm just going to run it for 30 minutes again and see how the Beast copes with both the CPU and GPU under load. So we're about 25 minutes into this CPU and GPU full system stress test, and as you can see, the GPU temperature is over 90 degrees, so running at 92.6 degrees C on the GPU core. CPU is also up at 90 degrees C, so it's getting really toasty inside the system now. You can feel the heat coming from it as well. There's a lot of heat coming at it. You can feel that natural convection is trying to pull away as much heat from the system as possible. In terms of individual CCDs, they both have peaked just over 90 degrees. One's a little bit hotter at 93 degrees C. CPU package power is at 125 watts, and because of the hot temperatures over 90 degrees, CPU core frequencies dropped to 3.55 gigahertz, and the GPU as well, that's dropped right back again. At one point it's below 1300, 1275 megahertz there, so 1260 it's dropped to at one point there. So it really is having to dial back the frequency to compensate for these high temperatures. If we just have a quick look at the GPU temperatures, so you can see it's running at about 92 degrees C on the GPU core. The memory junction temperature maximum reached 102 degrees C, and the hotspot temperature again is about 100 degrees C. And as you can see, GPU power is at 245 watts, which is within the spec of the heatsink. Yeah, you can see the minimum the GPU core has dropped to is 1245 megahertz. So I think I'll stop that test there. Just before I stop the test, I want to just have a look at something, because I know the back of these GPUs get quite warm. So just take that side panel off, and I've just got one of these cheap infrared thermometers. So I'm just going to see how warm that back plate is actually getting. So it says 86.8 degrees there, 85, 81. So right where the GPU die is, it is 86.8 degrees C. The heatsink fins, they're a bit cooler. They're at 57 degrees on the CPU side, 66 degrees on the GPU side. So just check that again on the back plate. Yeah, it's saying 86.5 degrees. That is hot. That is really hot to touch. You can barely touch it. The only thing I'm concerned about there with that kind of GPU temperature is if it did creep up a little bit higher than that and got over 88 degrees. That's kind of in the realms of you're wondering about the sleeving on cables. I know fan cables, they're usually around 88 degrees melting point, so that's something to be concerned about. Make sure that if you do build a system in here, you need to make sure that your cabling is nice and neat and tidy and isn't touching any of these places where it could potentially melt the sleeving on them. I doubt that would happen, but if the temperature did creep up a bit higher, potential for that. I also have run some more prolonged tests on the system, so I've run some 60-minute tests. Didn't see much difference really, just slightly higher CPU and GPU temperatures, but already at 90 degrees C. Everything's trying to dial back the frequency on CPU and GPU to keep as cool as possible anyway. I also ran the 60-minute tests with some fans installed because, like I said earlier, you can fit 240mm fans in the top of here. I had the fans running at about 650 to 700 RPM, so still extremely quiet with the system turned on with those fans on. It's virtually silent still as well. That did help reduce temperatures. I saw a decrease of about 10 degrees C on the GPU and the CPU with the fans installed, so I think if I was going to use this case, I would definitely install some fans because it doesn't seem to me like there's much point in even not running fans when it barely makes a difference to the noise levels. And that's the thing really with this system. I can't really see the point of running it in its completely passive mode, because unless you've got some real specific use or in a certain industry or a certain job where you need absolute complete silence of your system, I don't really see the point of running it in passive mode when you can stick two fans up there, run them on low RPM, and they're virtually adding nothing to the noise levels. In terms of gamers and just, you know, general use, maybe even video editing, I don't see why you need a completely silent system. As long as it's quiet and it's not disturbing, I don't see the point of it being any quieter than that. There obviously will be certain people that say, yes, you need a completely silent system for certain jobs, maybe if you're doing something with, you know, music or sound processing or something like that. But in that case, you could always move the system into another room and have extended keyboard, mouse, display cables, and whatever. So I don't see the point of it. So again, it brings me back to, do you really need this at all? I mean, you've seen that the traditionally cooled system with good quality, low noise fans seems to do a much better job. You don't have to compromise as much in terms of noise levels versus performance versus temperature. So I'm not really sold on the concept. I do see where there's been a lot of, you know, R&D engineering on the heat sinks themselves. They look like they've obviously been a lot of time spent on the design. They seem to be made well. They work well with the natural convection with the wider spaced heatsink fins. The main problem I've got with the Beast, just the case I'm talking, not so much the full system, is the build quality. There isn't a lot that's gone into designing the case. It's basically just two pieces of 6mm aluminium plate bent at the bottom to create feet. The build quality in terms of this top panel is not what I would call premium quality or high end, and also that grille at the top that, you know, moves about and it's really clunky and noisy, and that grill kind of reminds me of something that you'd probably find outdoors on like a barbecue or something like that. So it doesn't scream premium quality to me. Things like these clips that hold the tempered glass side panels on, I don't see those as being premium quality, or I don't see there's been a lot of thought that's gone into them. It's quite fiddly installing the tempered glass side panels, lining all four clips up at the same time, pressing it in position. You often find yourself pressing that hard that you almost tip the system over. I think a hinge system with a magnetic retaining clasp or something like that would have worked better. And also the powder coating on these special colour coatings that MonsterLabo do, it's not really up to a high standard. In certain areas, like on this top here, it's quite smooth and quite glossy, but then if you look at the front panel, you can see it's got like an orange peel effect. Being brutally honest, I'd say I could probably do as good a job in my shed with a rattle can, so it doesn't scream premium quality to me, especially when you consider the cost of this is going to be €800 just for the case. That's with no hardware inside. Obviously both of the heat sinks come and it's all pre-assembled, but still €800 is a absolutely astronomical amount of money for a PC case, especially if you think you can probably buy a good quality AIO cooler for around £100. Generally speaking, Founders Edition coolers and even AIB cards, if you pick the correct card, the coolers that come with them do a really good job. So I'm not sold on the Beast at all. It just probably didn't quite live up to my expectations. I was hoping that there would be less of a gap between the performance of the Beast and a traditionally cooled system. As I said previously, if you're running CPU intensive applications, then it's probably going to be sufficient, and obviously you got complete silence. But other than that, I'd still stick with your normal AIO or air cooler on the CPU and the stock GPU cooler, or if you want to spend extra money on your cooling, just go full custom loop. So thanks for watching, guys. I hope you've enjoyed this video of the MonsterLabo, the Beast. If you have, don't forget to hit the like button, subscribe to the channel. If you want to help support Kit Guru further, head over to our store and pick up some merch. And as always, if you want to catch up on the in-depth technical reviews, head over to the website.